Let's consider these three problems to help us with this idea of simplifying powers. The square root of x to the sixth, it's not simplified because 6 is larger than x squared, so there must be some factors of x squared in it. And indeed, that's what happens. We can write this as x squared times x squared times x squared. Now, there might be another way to write that. We could write that as x cubed squared. Okay. Now, if that's true, then our answer is the absolute value of x cubed. Because we can take the square root of something squared by removing that, throwing in the absolute values, and here we go. Now, if you're a little confused about the 3 and the 2, remember this is in between here, x squared cubed. But x squared cubed is the same as x cubed squared, so we kind of went roundabout that way. Once again, let's check this out. If I took 6 and divided it by 2, I'd get 3. Save myself these middle steps. Let's try that again. If I'm going to take x to the 7th, and I want to take the square root, I could write it like this. This would be the square root of x to the 6th times x. Well, I already know what x to the 6th is. It came out to be the absolute value of x cubed. And then we're stuck with this absolute value of x. And the reason it can stay under there is that it's not a perfect square. Well, at least we don't know it's a perfect square until we throw some numbers in there. But in the meantime, it's the square root of x. So again, we could take 7, divide it by 2, and we'd get 3 with a remainder of 1 this time. Let's take that now and apply it to a more complicated problem. First, we'd like to find the simplified version of the square root of 200. Well, how about 100 times 2? So that would be the square root of 100. If we take that square root, we'll get 10. But we're left with this 2 under the radical. So when we say we're taking a square root, what we're doing is removing the radical. Now let's look at the x to the 4th power. If we take x to the 4th power, if we take 4 and divide it by 2, because we're doing square root, we'll get x squared. Once again, do we need those absolute values? Well, whether x was negative or positive, when you square it, it's back to being positive. So the absolute values would be unnecessary here. Now let's see what we've got with y. We've got y to the 11th. Now we might think of y to the 11th as y to the 10th times y. Or we might just go ahead and use our division by 2. 11 divided by 2 is 5. So there'd be y to the 5th power here. And a remainder of 1 would mean that we'd have to put the y underneath the radical as well. Now, because this is an odd power, better throw in the absolute values, unless you're told that you know y is already a positive number. Okay. So there you'd have it. 10x squared, y to the 5th, square root of 2y. Do them step by step, factor by factor.